coordinates and basis. If I can just do one of these problems here, then I think that'd be great if I can. Um, we first introduced a basis. A set of vectors is said to form a basis for a vector space if two things happens. If the set of vectors, if they span the vector space, and if those set of vectors are linearly independent. So it's two very strong things, which sometimes it may seem like they both say the same thing, but they don't. It's a little bit different things about the vectors. Some common bases, we call them common or standard bases. So number one, if you have just a regular vector set of vectors like v1, v2, v3, then the standard basis is here given as number one. Now if you think about it, the standard basis will look like the skeleton form for the identity matrix. And that's the whole idea. Okay, so we've dealt with the reducing a matrix down to its identity. Basically, it's almost like kind of working backwards. That how do you, let's say, take something and you scrap it down to its chassis? Well, that chassis form is said to be the basis for it. You can put stuff on it, you know. And it's funny how they do cars, especially with the American auto industry. That a lot of vehicles have the same chassis, but they'll fix them up on the outside. And you know, you got a Yukon, you have a Tahoe, and you got that Denali, and you got the Escalade. It's all the same. It's the same chassis, right? So it's the same skeleton form, but you can put stuff on top of it. So here the skeleton form is said to be the basis, right? And so E1, basically, you can think about these as being the row, the column that stands up. This is the column with 1 at the first entry for E1, zeros below it. E sub 2 is the second column where we have a 1 at A22, zeros above and below, and so on. If it's a polynomial, what's the basis for the polynomial? Here the polynomial is of the nth order, the standard basis for P sub n, the space of all polynomials of the nth degree. It's the nth degree, but you have to also include the term that has the constant, you know, by itself. So here, what's that skeleton form? It's going to be 1x, x to the second power, all the way to x to the n. What about the space of all 2 by 2 matrices? What's its basis? It's going to be 4, and we'll talk about how you get the number for the basis. For a matrix, it'll always be, if you can find the basis, if it's an n by n system, it's going to be the 2 times the 2, or the n times n. That gives you the number of vectors or the number of matrices in that particular basis. So for the space of all 2 by 2 matrices, then here you get capital M1, M2, M3, M4 that form the basis, the skeleton form for any matrix that's a 2 by 2. Likewise for an n by n system. So here the standard basis for the space of all n by n matrices, you just expand number 3, expand that out. And so you get here matrices that basically you have a 1 in them, but you have zeros everywhere else. So, and that 1 is going to hold each position so that, let me give an example. So if you have the matrix A that has entries 5, 6, even the computer doesn't like Monday. You know, 5, 6, say -3 and 4. Well, this looks like 5 times 1, 0, 0, 0, plus 6 times 0, 1, 0, 0, plus -3 times 0, 0, 1, 0, plus 4 times 0, 0, 0, 1. these matrices with zeros and ones are said to form the basis. Right? Now, the numbers on the outside will actually give us what we call the coordinates. Okay, and we'll talk about that when we come back. Here, show that the following set forms a basis for R3. I may go over 3 or 4 minutes. Is that okay? Because if not, I can stop. But if I can go over 3 or 4 minutes just for this problem, then I'll be done. Stephen, is that okay? Is that okay? Okay, thank you. Show that the following set forms a basis for R3. To show that a set of vectors form a basis, you must do 2 things. You must, 1, show that the set of vectors span here R3, and then secondly, show that these set of vectors are linearly independent. And y'all know what? I'm getting hungry. I'm just going to stop right now, okay? And I finished this on Wednesday. I got some chicken noodle soup upstairs, and I want to go ahead and get to that.